Good day to you all from Australia. My name is Mariano Ramirez and I'm from the University of New South Wales in Sydney. I will be presenting a selection of Australian innovations in designing for other species, an approach that is known by many other names such as post-anthropocentric, biophilic, and ecocentric design. Wildlife overpasses or land bridges such as this one in Western Australia reconnect nature corridors that have been fragmented by highways. They are planted with native vegetation and enhanced with logs, rocks, and ponds to facilitate a seamless transition of landscapes. Photographic evidence show that this land bridge is indeed being used by native fauna, such as kangaroos and emus. Rope bridges have been suspended from poles above highway traffic to help tree-dwelling marsupials cross from one side of the forest to the other without having to descend to the ground. Additionally, these rope tunnels offer the animals protection from flying predators. Native arboreal mammals were quickly habituated to the rope bridges, particularly the gliders and the possums. During the first rainfall of the wet season in Australia's Christmas Island, about 50 million red crabs leave their homes in the forest and migrate towards the Indian Ocean to breed. Unfortunately, hundreds of thousands of these red crabs accidentally get crushed by motorists during this mass migration every year. Park rangers have installed fencing on the roadside verges to direct the crabs towards special crab underpasses. A steel overpass over the main road of the island has been successfully used by the crabs, and mortality has been reduced by as much as 80% compared to areas with unfenced roads. All over the world, honeybees are dying at alarming rates, and one of the factors is the Varroa parasitic mite. Australia is the only inhabited continent still free of infestation by the Varroa mite. These parasites attach, debilitate, and eventually kill the adult bees. Detecting and monitoring these mites is highly laborious and tedious. So in 2020, the Purple Hive project was launched to protect the Australian bee and honey industry. The solar-powered Purple Hive has computer vision cameras on the landing surface, which visually scans and analyzes each bee as it enters the hive, detecting any varroa mites which are piggybacking on the body of the bee. Artificial intelligence software and algorithms try to detect the parasite, and when one is found, an alarm signal is sent in real time to the beekeeper so that the affected hive can be quarantined. One of Australia's natural wonders is the Great Barrier Reef, but the corals there are under threat of predation by the crown of thorns starfish, also known as COTS. Each night, a single COTS can devour its body size in coral, and during severe outbreaks, entire reef systems can be quickly stripped of living coral. To control their numbers, these starfish need to be manually removed. Queensland University of Technology develops a COTS bot, an underwater drone that scans the reef for this coral eater and calls it through a lethal single shot injection of vinegar. And my last example today is the Living Seawalls project of the Sydney Institute of Marine Science and the Reef Design Lab. This involved microhabitat enhancing concrete tiles retrofitted to the sandstone embankments on the four shores of Sydney Harbour. The tiles mimic the complex root structure of native mangrove trees, which used to provide habitat for marine organisms but have now mostly disappeared in urbanized estuaries. So after 12 months, 66 species of oysters, barnacles, mussels, and other marine creatures have been observed on the living seawalls. I have presented half of the case studies that are featured in the full paper. All the cases were categorized and compared using the multi-species design cards developed by Dr. Daniel Metcalfe as part of his PhD thesis at the University of the Arts London. Metcalfe proposed 20 multi-species design processes that can be grouped into four main principles or categories, namely, treating nature as clients of design, researching other species in a design context, designing interactions between humans and other species, and designing like an ecosystem. This comparison matrix shows that overall, the 11 examples of non-anthropocentric innovations in Australia sufficiently comply with the principles and processes of multi-species design. Some principles were excellently demonstrated by all examples, particularly researching other species in a design context, while other principles could be explored more. I invite you to visit the full paper to see the other Australian examples of designing for other species and the analysis of the cases using the multi-species design principles. Metcalfe's framework provides a very useful addition to the toolbox of the 21st century designer and design thinker. Designing for all of life offers an avenue for innovators to learn to synergize their creative solutions with nature's ecosystems and to humbly appreciate the entanglements and complexities in the web of life on this planet, where humans are just one of the 8.7 million living species. Thank you for your attention.